a modal analysis of a turbine immersed in water. We'll begin by creating our simulation files, and we're going to create a modal solution 103, real eigenvalue. And we're also going to specify a parameter in the bulk data section for VM opt. We've made an improvement to the performance in Nastran in version 2506 with the implementation of VM opt 3. This will allow larger models to run faster. So we'll set VM opt to 3, and we'll give the solution parameter a name, and we'll create a normal mode subcase. We'll just take the defaults, which is going to be the first 10 modes. Next we'll go to the idealize part, where we're going to offset the wetted surfaces by 20% of our element size. And our element size is going to be 1/2 inch for this part. So we'll select the tangent faces. These are going to be all of the wetted faces of our turbine. Here you can see we're not wetted on the bottom or the inside. So 20% of our global element size is going to be 1/10 inch, and we've offset all of the faces inward 1/10 inch. The reason why we need to offset those faces to make the part a little bit smaller we'll discuss more in just a moment. But first let's go ahead and auto heal the geometry at a small feature tolerance of 1/10 of the global element size that we're going to mesh the part with. That will help to give a better mesh with fewer elements and better element geometry. Next we'll hex dominant mesh the part at a global element size of 1/2 inch. Now we don't need to specify a material property because by default we're going to inherit the material properties that were specified in the CAD model, which was 310 stainless. Since the fluid can only be applied to shell elements, which we'll be doing in just a moment, we'll need to surface coat the geometry. So here we've selected the same tangent faces that are wetted and have created a surface coat mesh of C-Quad 4 and C-Tria 3 elements. Here we'll need to specify the material since we're not inheriting anything from the mid-surface. Same with default thickness, we'll make that 1/10 inch, which was the amount that we had offset the geometry in the idealize part. Next we'll edit the mesh associated data to specify the physical property table for the thickness source and a shell offset equal to 1/2 of the thickness. So now if we were to display the shell element thickness, we'll see that that offset that we had applied earlier in the idealized part now consists of shell elements. Alright, so that looks good. Let's go to the sim where we can specify our fluid and our wetted surfaces. Here we'll select the simulation object virtual fluid, and we want to only select the elements wetted on the positive normal side. Here we'll select our surface coat mesh, and we'll specify a density for the fluid. Alright, so at this point we're ready to solve. Here I'll pause the video while it's solving. But you can see it takes about 4.5 minutes to run. And we can view our modal results. So here, since we didn't specify any constraints on the model, we just ran a free modal analysis. The first 6 modes will be rigid body modes. So we'll look at our first flexible mode, mode number 7, and we'll select the style to be modal and full cycle And let's bump up the number of frames so that our mode is a little bit slower there. And then we can step through mode 8, 9, and 10. And that's how to run a modal analysis of a turbine immersed in water.